Hello everybody. Now that we learned how to graph trig functions and write trig functions, now I can answer multiple choice questions based on trig graphs using ampersand freq shift, period equals 2 pi over the frequency, drawing a little picture, that's new, and adjusting the window in my calculator, that's new. There's a lot of different little types of questions in this lesson, which is why there's a lot in this aim. Let's get to it. In general, when you're given a trig graph and it's multiple choice or it's a modeling question, we want to draw a little picture. It's going to help me stay organized. Amp, sine, freq, x, shift. My shift is 7, so my midline is 7. My amplitude is 3, so it's going to be 7 plus 3 and 7 minus 3, which is 4. You might not need to write in those 3's. If it helps, great. But basically, I'm adding the amplitude and subtracting the amplitude from the midline to find my max and my min. Now, this may or may not be enough information. We may need the period as well. So, period is 2 pi over the frequency. Period is 2 pi over 3. Keep change flip, 2 pi times 3 over pi is 6. So this is 6. There is a phase shift here. We didn't talk much about phase shifts. It's really not going to matter. Based on the information I have right now, I should be able to answer the question. The period is 6, correct. The amplitude is 3, correct. The range is 4 to 10. Yes, my min is 4 and my max is 10. So yes, the range is 4 to 10. The midline is y equals negative 4. No, it's y equals 7. That is incorrect. So if they're asking you about components of a trig graph, draw a little picture. The midline goes at the midline. Your shift, add and subtract the amplitude to find the min and the max. Period equals 2 pi over the frequency. Once you do that, you should have enough information. So that's kind of the first type of question. Same thing here, same thing here, same thing here. It's really the same thing here. Let's go over this one. It might be a little confusing. It was a little tricky, this question. Because there's a phase shift, I'm not going to, well, let's not even say anything. Amp sine freq x shift. My shift is 7. My amp is 5. So it's 7 plus 5 and 7 minus 5. Period is 2 pi over the frequency. And again, you need to know, I'm not doing everything from scratch. You need to know all the lessons that came before this. So, make sure you know how to graph and how to write the equation and all that. Period is 12. So, the depth of the water in feet on a given day at Thunder Bay, T hours after midnight, is modeled by. Which statement is false? Well, we're going to hold off on 2 a.m. right now and 9 a.m. The maximum depth of the water was 12 feet. Yes. The difference in water depth between high tide and low tide is 14 feet. While high tide is 12, low tide is 2. So the difference between 12 and 2 is 10. So that's wrong. Which one's false? Choice 4. How would I do choices 2 and 3? Well, it says that T is hours after midnight. So 2 a.m. is 2 hours after midnight. And 9 a.m. is 9 hours after midnight. So if I want to know what the depth of the water is at that time, I'm just going to replace T with 2. I just finally streamlined this calculator, made it little again. I don't know what took me so long. So 5 sine pi, alpha x pi over 6 x, parentheses. Instead of x, I'm doing 2 minus 5 plus 7. I got 2. So yes, a depth of 2 is my low tide. So that is correct. And now 9 a.m., I can copy and paste that. So T is going to be 9 at 9 a.m. I got 11.3. It's approximately 11 feet. Yep, it's 11.3. So that's how I would determine if those are correct. If it's giving you a time, it's giving you T. You just substitute that value in for T. You didn't need to do that because it was very clear that choice 4 was wrong once I made my little picture. Same type of thing, same type of thing. Just, I don't want to go over this problem in detail, but the average monthly temperature variation, amp sine freak X shift. What component affects the variation? How far up and down it's going from the midline? Amplitude. If it's ever talking about variation or how much it's changing, that's the amplitude. Shift, the midline, so this is variation. Shift or midline is the average. And then anything with time is going to deal with frequency and more specifically period. So variation, how much it's changing from the middle, from the average is variation, and the average is your midline or your shift. So I'm not going to go over this problem, but in a real life context problem, amplitude again is variation, midline or shift is your average value. Pretty much the same thing. Relatively the same thing. Now we get into some questions dealing with period. Period is the time it takes to complete one full cycle, which we did in the writing lesson. In the lesson where we wrote the equation, we dealt with this. So looking at this graph, you need to identify the period, which we already did. It starts here, it ends here. The period is 2/3. Explain its meaning in the context of the problem. In general, the period is the time it takes to complete one full cycle. Time it takes to complete one full cycle. So you just need to give some context from the actual problem into what that full cycle happens to be. So in this case, we're talking about a bike wheel. So first of all, T is seconds. It takes 2/3 of a second for the bike wheel to complete one full rotation. It's going to always be the time it takes to complete one full cycle. Each question will have different contexts. You really need to be able to identify the period. That's very important. It's where the first full cycle ends, the time it takes to complete one full cycle. Which light wave has the longest period? Well, let's see. This one right here. It starts at this value. It gets back there. Back there. So that blue one, that's A. Let's go this one right here. It goes up. It comes back right around here. So that's B. And then C. It goes, it looks like it goes down a little bit. That's a little misleading. That doesn't even make the full cycle. I don't even see one full cycle here. It's like going to be way out over here. So which one has the longest period? I'm going C. So again, it's just identifying how long it takes to make one full cycle. The cycle ends when it gets back to where it started after completing, one full sine or cosine wave, which we spoke about in previous lessons. More about period. I guess we can take a look at this one. It's short. Again, period. One full cycle is period. And period is 2 pi over frequency. The frequency is pi over 3. pi's cancel. The period is 6. Be careful. Sometimes it might not ask for a full period. It might ask for half of the period. So you may need to cut it in half. Or a different fraction of that, but whenever it's talking about time, it's talking about period. Completing one full cycle is period. Period is 2 pi over the frequency. Same type of thing, and this is the final piece. We haven't used the calculator at all for anything with graphing trig functions until now. If it wants to know what happens to this graph from here to here, the easiest thing to do is to type it into the calculator, into the window. This is going to be my x min. This is going to be my x max. I can't type theta in. I'm going to type in cosine x into y equals, and I'm going to look at it. Y equals cosine x negative, I'm going to go to my window because I want to see the graph from negative pi over 2 to 0. Alpha x isn't working here for whatever reason, so we're just going to hit negative pi divided by 2. And I want my x max to be 0. Whatever I want to see the graph between, that's my x min and x max. That's it. I hit graph. What did I do? Oh, my window. I messed with my window before. So let's just go back to Zoom 6 first. Then let's go negative pi over 2 to 0. I do want to always start with my standard window, but I want to input the values that it's giving me. What's happening? Oh, it's going up, so it's increasing. Is it increasing from negative 1 to 0 or 0 to 1? Well, it's starting at 0. Starting at the x-axis at 0, and it's going up to 1. They want to know what's happening to a trig graph from 2 values. Input those values into your window. Type it into y equals. Look at it. Let's take a look at one more. Y equals 3 sine 1/2 theta. So I'm going to go to y equals. I'm going to type in 3 sine 1/2 x. My x min is going to be negative pi, and my x max is going to be pi. Y equals 3 sine 1/2 x. Window, x min is negative pi. Again, it's going to convert it to a decimal. That's no problem. Pi. Graph, it is increasing. The whole interval increases the whole interval. This has been coming up a lot post-pandemic. It didn't stop a little bit, but I would be prepared for this. It's not hard. The only time I'd use the calculator for trig graphs, if it wants to know what's happening to a graph between 2 specific values, type it into y equals. This is your x min, this is your x max. Input those into the window. Look to see what's happening. We haven't talked about tan. I think I have a tan example in here. Again, it doesn't matter. Type it into the calculator. Look at it. Tell me what's happening. That's it. A lot of little pieces, some themes that occur throughout this entire lesson. Ampersand, freq x, shift, period equals 2 pi over the frequency, and drawing a little picture really helps you stay organized with all your little components. Then specifically, if they're asking you what's happening to a trig graph between 2 values, adjust the window in your calculator so you can see what's happening between those 2 values. That's it. Practice it. Goodbye.